In this video, we are going to take a look at another problem, which is basically an extension of the previous problem that we solved in that in the previous lecture, and it says computer assisted instruction reducing student fatigue. Now the problem says one problem in Chi environment is student fatigue. Now this can be reduced by varying the computer's response to hold the student's attention. Now we are asked to modify the computer assisted instruction, that is the previous program that we created, so that the various comments are displayed for each answer as follows. So possible responses to a correct answer: very good, excellent, nice work, keep up the good work. And possible responses to an incorrect response: no, please try again, wrong, try once more, don't give up, no, keep trying. And where the program asks us to use a random number generation to choose a number from 1 to 4 that will be used to select one of the 4 appropriate responses to each correct or incorrect answer. So use a switch statement to issue the responses. So this is what the program is asking us to do, and that is what we are going to implement in this particular program. So basically it is just a little modification to the previous program that we created, so that it is going to be issuing either this positive feedback or any of these negative feedbacks, and using switch control structure. So what I'm going to do, I'll just go to the previous program that we created. I'm just going to copy it and then paste it in the new in that other new file that we created. So I just copy this, which is from chi1.c, and I'm going to come over here. I'm going to paste it, and then we are going to make the necessary modifications. So let me go back, go over and close this one. So now all the modification that we are going to do is this here. All right. So if you look at it, it says that we should modify the computer assisted instruction so that the various comments are displayed for each answer as follows. So possible response to a correct answer. So if the user get it right, the program should display one of this response: very good, excellent, nice work, keep up the good work. And if the user didn't get the response right, then it should display any of these responses: no, please try again, wrong, try once more, don't give up, no, keep trying. So what I'm going to do, we are going to implement 2 additional functions, one for positive feedback and the other for negative feedback. So that is what we are going to do. So I'll just come here over here where we declare the function prototype. I'm going to have another function again, and that the return type is not going to return anything. It will just print out a positive or negative response. For the first one, it's going to print out a positive response. So I'm going to name it positive feedback. So positive feedback, positive feedback, and it doesn't require any argument. And the other one, I'm going to name it negative feedback, negative feedback, and it doesn't require also any argument, no any argument. It's just going to print out a string. All right. So I'm go down and then implement the functions proper, and then I will invoke this function from function multiplication. So I'll just come over here at the end of the function multiplication. I'm going to have my first function, positive feedback, and as we declare in the function prototype, it's not going to require any argument when we invoke it. So we declare void as the parameter in the function definition header. So here we have positive feedback. All right. So what I'm going to do now, remember we said the program says we should use switch statement. We should use a random number generation to choose a number from 1 to 4 that will be used to select one of the 4 appropriate responses. As when we look at the responses, there are 4 responses here. So we use a random number generation to generate a random number from 1 to 4. So what I'm going to do now, I'll just come here. I'll have my switch statement, switch, and then I'll have my block in the switch, and then let me make a comment here: and switch, and then I'll have my first case 1, and then I'm going to print out the appropriate response for case 1. So for case 1, I'm going to have what? The first string for positive response, it says very good. So let me copy this one, very good. So I'll just go down there, and then I'm going to print under case 1, print format, very good, and then print the string here like this, very good. So this is for the first case, and after this you just break from the switch case, break. Then we'll go to the second case. For the second case, case 2, what do we want? We want to print the next string, print format, very good. The other one is what? Excellent. Excellent. So we just go down and print excellent. Excellent. And for third case, case 3, what we want to print? Okay, we what are the break? We need break. Break is very important so that it will break from the switch structure. So we'll go over again, case 3, the next one, nice work. So nice work, nice work. So we have here, now we have print and nice work. Then we have the fourth case, case 4, case 4. Okay, here break, break. Then case 4, what is the fourth case? What are we going to do? Keep up the good work. We should print this particular string, keep up the good work. So I'm just going to copy it and then keep up the good work, keep up the good work, keep up the good work. Come here, print it. Let's keep up the good work. Print format, keep up the good work. So I have this, keep up the good work. So, and then also break and break. So these are the 4 cases that we're going to have. We haven't created the in the switch parenthesis, we didn't put the value that the switch is going to match against these cases. So what I'm going to do, I'm going to make use of function rand, a random number generator, to generate a random number. Okay, so what I'm going to let me see. Okay, I'm going to say value, since an expression is allowed within the switch, rand equals to okay, rand modulo 3. Right, yeah, modulo 4, which is going to generate for me going to generate numbers 0 from which is going to generate numbers for me that are less than 4. So rand can generate any number for me. We have already seen this. Rand function rand will generate any number for me, 1 million, 1 trillion. But whatsoever number I generate, when we divide it, since we say modulo 4, when we divide it by 4, the remainder will always be less than 4. So we can have numbers such as 0, such as 1, such as 2, and such as 3. So now, but we want a number from 1 to 4. So we can increment, we can have something like this, so that when we have 0, it will add 1 to it, so that it will be 4, so that it will be 1. When we have number like 1, it will add 1 to it so that it will be 2. When we have 2, it will add 1 to it so that it will be 3. When we have 3, it will add 1 to it so that it will be 4. So in essence, what I'm saying 1 plus this particular something that I'm going to put in this particular parenthesis. Okay, is it right? Is the parenthesis? Okay, I need to add additional parenthesis. So what let me space it out to be more clearer. First of all, we have within this innermost parenthesis, we have rand, function rand, which generate any number modulo 4. It is going to be less than 4. So it's going to be 0. It can take the values 0, 1, 2, 3. So whatsoever we have, we are adding 1 to it, and then we have the value. That value is going to be matched against any of these cases. All right. So that is what we are trying to implement here, and this is the end of this particular function. So I'll have it here as end function positive feedback. Now the next thing is function for negative feedback. So I'll just copy this one, since it's just a variation of this, only the string that that we are going to print out that changes. So I'm going to paste it here, and then I'm going to rename it to negative feedback. So negative feedback, and then we have these cases. So I'll go over and see the appropriate message we should print in case the user fails the question. No, please try again. So let me copy this one. No, please try again. No, please try again. So let me have this one for the first one. No, please try again, without the exclamation mark. And this is a negative symbol, a negative message. So let me use a dash. So I'll go over again, and this is the next message. Wrong, try once more. So I'll copy this one here. Also, I'll go over and replace it with that. So we have this. Wrong, try once more, and then replace this one here. Now I'll go back over there again, and then see what is the next something. Don't give up. So copy it. Don't give up. So we'll just go over down, and see what I'm going to do. Don't give up. The dash here. Now the last message, the last message to be printed out, or the last message to be printed out. No, keep trying. So just copy this one. No, keep trying. So I'll go down. Okay, come here. Then I'm going to paste it. So change this one to a negative symbol. End function negative feedback. Now I have successfully implemented my two functions, but the functions are redundant. No ending line of code is invoking these functions. So now we are going to go to function multiplication and then see the appropriate point where we can invoke these two functions that we created. So as we can see, line number 65, that is where we are printing a negative response. So instead of printing a monotonous statement, just a single statement every time the user fails a question, because that is the essence of this particular modification that we are doing to this program, to make the program more interesting, more interactive. So instead of using just a single feedback, we should vary the responses. So we are going to invoke function negative feedback. So instead of doing this, we invoke function negative feedback, and just to invoke function negative feedback, we just write the name of the function negative feedback followed by the parenthesis. And remember, the negative function negative feedback doesn't require, we didn't define any parameter in the function definition header, so we are not inputting any argument here. So also in the case where the user get the question right, we are going to invoke function positive feedback. So instead of printing this message in line number 73, we are going to invoke function positive feedback. So then that is all. So now I'm going to save it. Now let me go to the terminal and then try to compile this program, run it, and see whether everything is all right. So here we are, and let me just minimize this one. All right, so let me just create something. Cd document programming. Let me clear the terminal, and then cd c lectures. So clear the terminal again. So gcc, we have chi2.c. We have chi2 .c. I want to output it as chi2. All right, so I hit enter. All right, I have an arrow. I have an arrow which I need to go and fix the arrow. So yeah, so we have we didn't declare the variable value in line number 86. So let me go and fix that issue. Line number 86 and line number 108. So we have to declare that particular variable. 1 plus rand modulo 4. All right. All right. So do we even need this particular something? Let me just do away with it. We just have an expression 1 plus rand modulo 4. Instead of doing that, let me just do away with that particular variable. Let me just do away with it. Okay. All right, and then there are some print statement that we didn't. Okay, this is one of those statements. Put the statement terminator, and then we also have it here, statement terminator. So I will save it, and then go to the terminal and try to see whether it will compile successfully. So perfect, our program has compiled successfully. Now I'm going to run this particular program, chi2.c. So chi2 only, since this is an executable file that we are running. So we are not running the source code, we are running the object code, the executable code, the executable file. All right, so chi2, I'm going to run it. How much is 5 times 7? 35. Excellent. How much is 2 times 5? 10. Excellent. How much is 4 times 2? 8. Very good. How much is 3 times 0? 0. Excellent. How much is 0 times 7? 0. Excellent. How much is 0 times 3? 0. Keep up the good work. So as we can see, the positive responses are coming randomly. We have excellent, we have very good, we have keep up the good work. So let me put the wrong response now and see. 7. No, keep trying. No, keep trying. All right, so let me 5. No, please try again. Let me put 4. Try once more. Let me put 6. No, please try again. So what was the equation? How much is 0 times 2? How much is 9 times 6? 9 times 6. 9 times 6. How much is 9 times 6? 9 times 6. I actually need to use a calculator. So let me quickly use a calculator and find it, and then I can be able to give the right response. 9 times 6. 9 times 6. So I can see 9 multiplied by 6 is 54. So 54. Excellent. So let me exit the program now by entering -1, and now the program exit. So I want to make a little modification so that when we have a negative response, it will be like a prompt. It will look like a prompt so that the user knows that he needs to enter the appropriate. You need to re-enter the answer again. So no, please try again. Let us have a prompt like this. Also, let us have something like this. Don't give up. Something like this. Also here, something like this. Let me save it. So let me go and compile it and then run it and see. So let me clear this and then so then we compile it again. 0. Don't give up. 4. Don't give up. 2. Don't give up. 1. Don't give up. 5. Don't give up. 6. No, wrong. Try once more. 8. 7. 8. 3, 2, 1. So what is the right answer? How much is 9 times 5? 9 times 5 should be 45. Excellent. So as we can see, this program is working perfectly. So let me enter -1 and exit the program. So we have successfully tackled this problem. So please, you can share this tutorial so that other people will also benefit. And please, if you haven't subscribed to the channel, please subscribe to my channel and like and comment if you have any question pertaining to this particular lecture. Thank you.